Today's video we're going to talk about how to determine if something is a solution to an inequality. This is part of Unit 5, so our color is yellow. There are two methods for determining which numbers are solutions to inequalities. Method number 1, solve the inequality, treat the given numbers as test cases to see if they make the solution true. Or you can use method 2, plug the given numbers into the inequality directly and simplify. Decide if the resulting inequality is true or false. So we're going to show both methods today, and then you can decide which one you like the best. So my first inequality is 9 plus a is less than 17, and I'm trying to determine which number is a solution of the inequality. So for method 1, I'm going to go ahead and solve this inequality, and then see if 7, 8, or 9 makes the inequality true. So start by drawing my line down the middle. 9 is a positive 9, the constant's out in front. In order to cancel a positive 9, I'm going to need to subtract 9 from both sides, and I'm left with a. Since I use subtraction, I do not need to flip the inequality symbol, so I have less than, and 17 minus 9 is 8. So I have a is less than 8. So then I'm going to plug in 7, 8, and 9, and I'm going to see which one makes that true. So if I have 7 is less than 8, that is a true statement. So I know that 7 is a solution. I'm going to test all of the numbers just to be sure. I have 8 is less than 8, which is a false statement. 8 is equal to 8, so I know that 8 is not a solution. And 9 is less than 8, which is also a false statement because I know that 9 is actually greater than 8. So one common misconception or one common mistake that 7th graders usually make is they get the number 8 here and they're quick to jump on 8 as a solution. But because this is less than, not less than or equal to, the correct answer to this question is actually 7 and not 8. So you have to be very careful, and that's why it's important to take a minute to actually plug in each of the answer choices in order to determine which one makes the inequality true, and not just pounce on the number that you get when you solve the inequality. All right, question number 2. I'm going to use method 2 this time. So I'm going to plug the numbers directly into the inequality and then simplify. So instead of solving, I'm going to plug 14 in for b. So I have 14 minus 10 is greater than 5. 14 minus 10 is 4, so I have 4 is greater than 5, and that's false. So I know 14 is not a solution. Then I'm going to plug in 15. I have 15 minus 10 is greater than 5, and that gives me 5 is greater than 5, which is also false. 5 is equal to 5. And again, I don't want to automatically pounce on 5 just because I see that number. So 15 is false as well. And I'm going to try 16 minus 10 is greater than 5. 16 minus 10 is 6. 6 is greater than 5, so that one is true. So when I end up with a true inequality, that means 16 would be my solution. So again, two different methods. You can solve and then plug in, or you can plug in and simplify. You can choose either method you like. All right, number 3, we're going to go back and we're going to try method 1. So I'm going to solve this inequality, and then I'm going to decide if 15 is a solution or not. So in order to solve this, I see minus 5, so I'm going to need to add 5 to both sides. And that gives me x is less than 10. If I plug in 15 for x, I treat it like a test case. 15 is less than 10. I know that this is false, so 15 is not a solution. All right, in example 4, I'm going to go back and do method 2 again, where I plug directly in. So I'm going to plug in 3 for n. So I have 32 is greater than or equal to 8 times 3, which gives me 32 is greater than or equal to 24, and that's a true statement. So 3 is a solution. Again, either method. Plug in first and simplify, or solve and then plug in. Again, you can choose. All right, last 2 examples. I'm going to do method 1 and then method 2. Which of the following numbers is a solution to the inequality? So in this case, I have 16 is less than negative 8x. So I'm going to solve this inequality first. I see multiplication. I have a coefficient times a variable. The number and the variable are right next to each other. So I know I'm going to need to use division. So I have to divide by a -8. I'm dividing by the same number that I multiplied by. I have -2 and x. And because I divided by a negative right here, I'm going to have to flip my inequality symbol. So this sign becomes a greater than, since I divided by that negative. All right, and then I'm going to start with -2, 2, -3, and 3, and I'm going to plug them into my solution. So letter A, I have -2 is greater than -2. That's false. They are equal to each other. And again, a lot of 7th graders will say, oh, -2, my answer is A. But if I actually plug -2 in for x, this is a false statement. So it's not A. All right, B, I have 2 is greater than 2. That is a true statement. 2 is indeed greater than, -2. So I think my answer is B. I'm going to test the other two just to be sure. All right, C, I have -3 is greater than -2. That's false. -3 is less than -2. And then last but not least, D, I have 3 is greater than -2, and that is a true statement as well. So this particular problem has 2 answers. On your standardized tests, your SOLs, there are questions that have more than one answer. So it's very important that you check A, B, C, and D, not just assume that the first answer you get is the only answer. All right, question number 6. I'm going to use method 2, so I'm going to just start by plugging in these numbers for C as opposed to solving. So I'm going to start with letter A, and I have 15 minus, I'm going to replace C with 3, is less than 12. 15 minus 3 is 12, so I have 12 is less than 12. That's a false statement because they are equal to each other. They are not, 12 is not less than 12. I have 15 minus 4 is less than 12. That gives me 11 is less than 12.
But B works. All right, we're going to test C and D as well. So I have 15 minus, C is -3, is less than 12. If I use KCO, that gives me 15, keep, change, opposite. So the opposite of -3 is 3. This gives me 18 is less than 12, and that is a false statement. So C is out. And last but not least, D. I have 15 minus -4 is less than 12. So 15, keep, change, opposite. 15 plus 4 is less than 12. 15 plus 4 is 19. And that says 19 is less than 12, which is also a false statement. So D is out as well.